In this episode, we're looking at investigating reversible changes. Hi, boys and girls. At the end of this lesson, you'll be able to define reversible change, carry out fear tests to demonstrate, and use scientific language to explain reversible change, infer that some materials may change from one state to another, identify the processes involved when materials change from one state to another, and finally, complete at least 4 of the 8 activities at the learning centers. Materials exist in 3 states: solid, liquid, and gas. In our everyday life, these states of matter make changes that can be reversed or undone. These changes can be observed by feeling or looking at the texture, shape, temperature, and state of matter. An example is the melting of ice to liquid, and then after freezing, it reverses to ice without forming or producing a new substance. So, very important. When we think of a reversible change, no new substance is formed. So reversible, another way to think about it is like tying your shoelace, and then you untie the shoelace. You still have the same shoelace. Nothing new has been formed. Figure 1 shows reversible changes in our everyday life. Let's go. At the center, we have reversible change. Examples: melting, freezing, mixing, dissolving, boiling, evaporating, and condensing. Okay? So we can melt some butter, and then we can put it back in the fridge, and the butter is still there. Nothing new. We can freeze some water, and then we can melt the water. We still have water in different states. We can do some mixing of certain things, right? And we reverse that, and we still have the original things. We have some peanuts, and we add some raisins to it, and we can separate those. Nothing new was formed. Dissolving, we could add some salt to water, and then via evaporation we get back our water, and we get back the salt. The water will change state, and we get back the salt. Boiling, again, boiling the water, and condensing. So when we cool the water that has evaporated, it will now go back to a liquid state. So all of this is what? Reversible. Examples of reversible change. Here's a group activity. Carry out an investigation to demonstrate a reversible change. Material, a balloon. Method, the how we do it. 1. Observe the size of the balloon. Now blow air into the balloon until it inflates. Make an observation, then let out the air from the balloon until it deflates. Make and record your observation. Repeat the activity. However, this time, use a pencil and burst the balloon. Make an observation, then record your observation. Access the internet and download and view videos on reversible change. Explain. Complete table 1 by writing each answer beside a number and letter for the action taken. New material, substance formed, new material or substance formed, and whether or not the change is reversible. See the examples, and table 1 is here. Rubber band, action, no change, it is reversible. So we could stretch the rubber band, right? That will not produce any new material or substance, and it can, go back to its original state. Ice, what could we do? We could do some melting, right? No new substance is formed, cool, and it is reversible. Inflated balloon, some the bursting of the balloon, no new substance will be formed. The balloon will be in pieces, but still the same balloon pieces, right? So it's reversible. How practical this is, I'm not certain, because you can't fit the balloon back together to get it to work. But the definition says no new substance is formed. Deflated balloon, the action, we could inflate the balloon, no new substance will be formed, and it is a reversible change. Extend. Use a digital device to take photos of the investigation. Label the photos before and after. So you blow up the balloon, that's the before, and you deflate the balloon, that's the after. We have liquid water, and then we freeze the water, it now becomes ice before and after. Evaluate. Complete at least 4 activities from the 8 learning centers. Wordling from the Faye Ellington Center. Make bookmarkers. On each include the definition and an example of reversible change. Self-link from the Dr. Agri Irons Center. Make a journal entry expressing your view on reversible changes. Music link from the Jimmy Cliff Center. Write song lyrics for reversible changes. Picture link from the Edna Manley Center. Download photos on reversible changes, then create a carousel of these images. Body link from the Rex Nettleford Center. 1. Observe a sheet of paper. Fold the paper into 8 equal parts, then try to reverse this change. Observe the activity, then record your observation. Number link from the Albert Einstein Center. Use figure 1 to respond to each question. What fraction of the materials represent a reversible change? What percentages do not represent reversible changes? Social link from the Mary C. Cole Center. Use a device and take photographs of the group activity. Share the images in your class WhatsApp group. Nature link from the Dan Macaulay Center. Observe nature and identify reversible changes that take place. In this episode, we were looking at investigating reversible changes. So, we should now be able to define a reversible change. We should be able to identify or state fear tests that could be done to demonstrate reversible changes, and use scientific language to explain a reversible change. We should be able to now infer that some materials may change from one state to another, and we should be able to identify some of the processes involved when materials change from one state to another. You should also have completed 4 of the activities at the 8 learning centers, and we want you, as usual, to record one of those activities and post here. Take care. We'll see you in our next episode.